Uh, Hi everyone, good evening all. It's privilege to have Nisar here. Uh, on behalf of Chennai, welcoming Nizar. He'll take us through the webinar on Sitecore Docker from Zero to Hero Part 1. We are eager to hear from you, Nizar, and welcoming all the participants on behalf of Chennai. Over to you, Nizar.
Yeah, thank you, Vinodini. Thank you all for joining the session. I have planned to take a few sessions for Sitecore containerization. As you know, it's a hot topic in the Sitecore community. I have categorized the session into Docker and Kubernetes series. We may require minimum 3 sessions for each series. Today, we can start with Docker. So this is the agenda for the session. We'll start with organization challenges. Then we'll see what is the difference between VM and container, what benefit it brings to the business, container-based site code development. Then I'll cover Docker overview and its terminologies. Also, we can see how to set up the environment and run our first site core instance on containerization. Finally, I'll show you some CLI comments. Then we can close the session with Q&A. Currently, organization faces a lot of challenges. I have listed some of those here. They are wasting a lot of time setting up Sitecore environments, and they are not able to replicate specific environments quickly. It is mainly needed for replicating production issues. It is difficult for the organization to manage different Sitecore projects. Switching between the Sitecore project is taking time. And also it is difficult to manage its infrastructure because of varying dependencies between the different version of Sitecore. Varying dependencies means different version of Sitecore has different dependencies. For instance, Solar version, SQL versions. Also, the current DevOps flow is generating a high cost of infrastructure due to the overuse of resources needed by the virtual machines. And finally, various environments are deployed on multiple cloud hosting. In such cases, we need to have a cloud specific configuration. Hope you all agree with the challenges. Now we'll see what is container, and if business adopt containerization, then how all the problems will be solved. Containers are executable units of software that code is packaged in along with libraries, dependencies, and configuration so that it can be run anywhere, whether it is an developer workstation or an on-prem server or in the cloud. Okay, so it can be run anywhere. So before seeing the benefit, we'll see what is the main difference between VM and container first. So instead of virtualizing the hardware stock, container virtualize the operating system level. If you see the image, VM has its own OS. VM has its own OS. Okay, but container shares the host OS. See here, the container share the host OS. Okay, so it is more lightweight since they share the OS kernel. So it starts faster and uses only fraction of memory compared to booting an entire operating system. Okay, so that is the main difference between the VM and container. As I said, if business adapts containerization, then all the problems the organization facing currently will be solved. And also they will get a lot of benefits. Few are listed here. First one is faster time to market, which means faster local development setup times, smoother deployment flow between environment from dev to prod, and no works on my machine scenario, which means it is working in my machine but not working in dev or prod. Those scenarios will never come to picture because we have packaged the dependencies as well here. Reduced mean time to resolution. Here, supporting quickly replicate production environments locally so they can work on fixing issues sooner. We can take production image and add, and by executing a few commands, containers can be spin up with the full functioning system. Okay, so then easy to manage different site core projects and its infrastructure. Here, switching between the project can be done in a few commands. I will show you how to at the time of demo. Then low cost of operation. Fewer resources are only required to run the containers on the host since the operating system kernel is shared. Finally, the flexibility in the cloud. Containers can easily move between different cloud versions since everything is packaged in along with libraries and dependencies. Here, no need to have cloud specific configuration. Okay, now we'll see container based Sitecore development. Okay, as you know, Sitecore moves towards microservice based architecture. Container lend themselves very well to this architecture. No installation using SIM is required here. Sitecore provide container images which are ready to use. You can get the instance up and running with few commands. That's it. And simplified onboarding, which means install pre-request is just clone the repository and run Docker compose up. That's it. You can onboard your Sitecore instance quickly. Then multi-project efficiency. You can run multiple Sitecore instance simultaneously without worrying about things like conflicting version of SQL and Solar. You can start and stop entire instance quickly when jumping between the project. For example, if you're running XP1, okay, XP1 scale, okay, you can just Docker compose stop that instance will be stopped. Then you can simply go to XM instance and you can up the instance by executing the command Docker compose stop. That's it. Environment consistency and stability, because containers are immutable, which means once the container is restarted, the changes will be gone. In this case, you don't need to worry about running your local instance by copying the production image. Hope you all understood the benefit of containerization. Sitecore adopts containers as a cloud technology of choice. They will stop provisioning ARM templates and Sitecore web deployment package. They will support pause for some time, but still the container is recommended. So it's a time to adopt it. So we can start adopting it. Okay, Docker versus Kubernetes. Although many people want to compare Docker and Kubernetes, it's not actually an either or question. Docker is a containerization platform, and Kubernetes is a production grade container orchestrator for container platforms like Docker. Okay, to make more simple, okay, in simple words, Docker is used for building application running on containers. Whereas Kubernetes helps you to deploy and manage containers in production. These two are two different things. Okay, we'll understand Docker in detail in coming slide, and we'll plan some dedicated sessions for Kubernetes. Let's start with Docker. Okay, actually, Docker is a company. They also own Docker Hub, which is officially a official registry of Docker, where all the images are available to download. They also develop Docker for desktop tool. Using that tool only, we will do our local development. We can say it's an open source project, okay, for building application on containers. Docker has become synonyms nowadays with containers because it's been very successful. Docker was originally built for Linux, but now it runs on Windows and Mac OS as well. We need to understand different Docker terminologies in order to work with Docker. I'll explain one by one. We'll start with image. Image is a package with all the codes and dependencies. It serves as a blueprint for creating container. An image is often based on another image with some additional customization. Okay, so image themselves are built on the concept of layer. Each layer is building upon the layer below it. This concept makes it very simple to customize the existing images to build your own custom functionality. If you look at the image, you can see the Sitecore experience platform image is built on top of the 4.8 Windows Server Core long-term support 2019 image. Okay, they took Windows Server Core image released by Microsoft and added custom layer on top of it to include Sitecore code. If you look at the middle image, Sitecore PowerShell extension is layered on top of XP. So here XSA is layered on top of SPE and XP. Okay, so like that they are layering. The layered approach has another benefit as well. Once the layer is downloaded, it will not be downloaded again while pulling a new image. So we'll save disk space. Starting with version 10.0, container images for all roles and topologies are available at scr.sitecore.com. This is the official container registry. You can download all the images from that registry. Okay, so the next terminology is Docker file. Docker file is a text document format that contain instruction for assembling Docker image. This file is used by the Docker CLI build command to build the image. This is the example for the Docker file, which is used to build. So this example I have taken for Sitecore solution image to build the custom solution image. We have Docker file for all roles as well. Okay, we can create a number of Docker files based on your requirement. Then the next terminologies are registries, repositories, and tags. A registry is a place where you store image. This can be either a public registry or private registry. An example of public registry is a Docker Hub, and a private registry is Azure Container Registry, Amazon Elastic Container Registry. You can say use. Once you build your own image with your custom solution and modules, you can push it to registry. Okay, and you can download the images at the time of deployment by configuring your CD pipeline. In the registry, we will create repository. A registry can have n number of repository. A repository contains a collection of images with the same name, labeled with tags to indicate the version. In an image reference, if you see the image reference, this one, the mcr.microsoft.com Windows/server core is the registry name. Okay, which is always in the before the final colon. Okay, a tag is a reference to a specific image within the repository. In an image reference, this is the part after the final colon, and it is often used for version number. Okay, for example, in this image reference URL, the long-term support 2019. Okay, the one with after the final colon is called as tag. Okay, I'll go in detail about this registry and repository when we are working with Kubernetes session. Okay, you can push the solution image or any role like CM with solution code to repository with the tag like v1. If you are making any additional changes to the solution, it can be tagged with version 2 and can be pushed to the repository. With the help of this version control, you can roll back easily to the version 1, simply changing the image reference. Okay. So that's all about registry, repository, and tags. So as I told, container means it's an instance of image. It consists of content of Docker image and an execution environment. Then finally we have compose and orchestrator terminologies. A compose is a CLI tool and a YAML based text format document created by Docker. You can run image directly to create container, whereas you can use Docker compose to define how multi-container application run. Sitecore is the perfect example for this multi-container application. Here each role will have a container. After you create the definition for each role, you can deploy the entire multi-container application with a single command, Docker compose up. So it will compose together into a fully functioning system. Okay. That is the purpose we are going for a compose file. Then orchestrator, okay, a management tool for container. As I said, it helps you to deploy and manage containers in production. Kubernetes is the most used, and it is well supported by Microsoft through Azure Kubernetes service and Amazon through Elastic Kubernetes service. So to summarize, okay, the terminologies. Okay, so first we will create a Docker file. As I said, if you build the Docker file, you will create you will get a Docker image, and you can run the if you run the Docker image, you will get a container. Okay, the container will be spin off. You can also push the images into the registry uh, under a repository, and you can pull it at the time of deployment by configuring CD pipeline. Okay, If you're running multi-container application, you can go with Compose. Okay, the Sitecore has to use Docker Compose because we have many roles. It's a best example for multi-container application. So you have to write Docker Compose file. When we go to production, we will be using orchestration tool. So for this purpose, we'll be using Kubernetes. I will cover that in the Kubernetes session. Hope you guys you have understood. Okay, and now we'll see what are the prerequisites to set up the environment. Software side, we require Windows 10, 1809 or later version. Okay. We can also use Windows Server 2016 or 19. For that also we require 1809 or later version. And we have to install Docker tech stuff for Windows. Um, while we are installing, it will ask for enabling Hyper-V. We should enable it. Okay, so virtualization is needed here in order containers to run. Hardware side, we need minimum 16 GB of RAM. But if you want to use XP scaled and all, you have to minimum have 32 GB is recommended. Okay, and CPU, we need hot core processor or higher, and minimum 25 GB free space is required. Okay, so this Sitecore will be using Terrafic as a reverse proxy to redirect the request which we receive from the client or user. Okay, so the Terrafic is using the port 443 and 8079. And as you know, right, we'll be using Solar and SQL. Solar is using the port, default port is 8984, and SQL default port is 14330. All these ports should be free. Okay, suppose if you are already in your virtual machine, you are already running any Sitecore instance. Okay, this port will be might be already used. Okay, so if you are running container in that machine, then it won't run. Okay, so before running a container, better you can stop the IIS, then the port will be freed, then you can run the container without any issue. Okay. Okay, so now we'll see how to set up and run our first Sitecore instance. Quickly, we can get an out of the box some single instance up and running with minimal configuration. I'll explain the approach now. You can use the same approach to start any configuration. Okay, you can download the container package from dev.sitecore.net. I can go to that dev.sitecore.net. So here you can see there is a download option for 10.1. Now from 10.0 onwards, they have introduced an option, download option for Sitecore container deployment. Okay, so here you can see the container deployment package. You can download that, and the required Docker files and the supporting files, everything will be there in the package. And by following the installation guide, you can set up your developer workstation. And also they have provided installation guide for production environment with Kubernetes. Okay, so this is the one of the option you can download and you can use it. And we have another option as well. So there is a Docker example repository the community and Sitecore has built. Sitecore. Okay, so this is the repository. You can just clone this repository, and with that, you can see here there is a getting started folder for a vanilla Sitecore instance. Okay, and we have they have given custom images. Okay, with you can customize it and you can build your own images as well. Okay, so I have cloned this. Okay, already. I can show you now. It's a time for demo. Okay, so see here I have already cloned it. Okay, so as I told now, just navigate to the getting started folder. Okay, so this is the folder used for vanilla instance. Today I'll show you how to set up the vanilla instance and make the first Sitecore instance up and running. Okay. Before that, I'll show you what folder and files it contains. So inside this getting started folder, you can see we have MS SQL data, Solar data, Terrafic folders, and we have environment file, Docker compose file, git ignore, and init clean scripts. Okay. So first one is Docker compose YAML file. Okay. So if you look at the file closely, this compose file is the main configuration file used by the Docker compose command. Okay, it contains information about the different containers referred as services. So if you see here, we have Terrafic service, we have MS SQL service, and we have Solar service and Solar init service to create cores, Solar cores, and we have identity service, and we have CM service, Xcanite, and so on. Okay, so these all are the service. Okay, so for each service a container will be getting created. Okay, the services are generally represent the individual Sitecore roles, as I said, that make up the topology. Okay, so this all about the compose file. I'll go in deep. Okay, if I have a time in this session or next section, we will discuss in detail about this compose file. Then we have environment file. This environment file contains values, provide default values for environment variables referenced in the compose file. For example, if you look at the compose file, okay, so here, okay, so if you go to MS SQL, okay, service, okay, here you can see they are taking the Docker registry, the SQL password, and admin Sitecore admin password, everything from the environment variable. Okay, so all these all declared here. See, Sitecore Docker registry, the one which I explained at time of image. Okay, the which Sitecore version. Okay, and what is the SQL password and Telerik encryption key and identity certificate and Sitecore license. Sitecore license also converted as a base 64 format, and you can find here Sitecore identity certificates and everything. So like that, what are the environment variables we needed to be referenced in the compose in the Docker compose file? We can reference here and we can use it. Okay, so that is the main purpose of environment file. So in a single file, we can change it will reflect across all the required area. Okay. Then we have MS SQL data folder. Okay, and we have in the this is a supporting folder utilized by the Docker containers within your Sitecore instance. It is also included in the Sitecore container support package. The MS SQL data are used as a persistent storage for the database file. Okay, these are our database file. Okay, even you down the container, this database file will be persistent. Okay, so you can utilize it. Then the Solar data folder contains all the Solar cores, which is also persistent. Okay. Then we have init and clean script. These all are supporting script which is not part of the Sitecore container support package. Okay, this is built by the community. Okay, so this init PS1 perform all the operation steps automatically. Okay, so before you start Sitecore, first you have to run this init PS1. Okay, so go to this getting started folder into the PowerShell and run this init PS1. Okay, so while you are running init PS1, it will ask for license, provide the license. Okay, then it will create Terrafic and related certificates config, and it will populate this environment file with the values. For example, it will convert the license file into the base 64 format, and it will create a default password, Sitecore admin password, everything it will do. Then you don't need to manually do step by step. Okay, so to start the Sitecore, so already I have we have downloaded everything. I have already ran init PS1. Okay, Okay, so now I already into the getting started folder. Okay, so this is the folder. Okay, so here we have Docker Compose YAML file. So using that file, we have to spin up the containers. Okay, so I'm gonna type Docker Compose up hyphen D. Okay, so while I up the Docker Compose file, so what it will do in generally, okay, it will download all the required image from the Sitecore container registry. So see here, we have all the roles defined here, Terrafic for reverse proxy, MS SQL. Okay, see here we have given the image path. So Sitecore Docker registry, if you go to the environment file, you can find, you'll go to scr.sitecore.com/xp, and it will find for a Sitecore XP0 MS SQL image with the version 10.1.0 long-term support 2019. Okay, so it will so what it will do, it will download the image. Okay, and it will create default network. Okay, so we have different services. Okay, different containers. Okay, as I said. Okay, so this container has to be communicated. For example, if user is accessing a CM container, okay, the request will go to Terrafic. Terrafic will define where it has to go, either to CM CD. So, and CM will needs to be communicated to MS SQL or Solar. So all this communication will be taken care on network. So I'll explain network in detail in the coming session. Okay, so the network will be getting created. Second step, and third step, the container will be getting created for each configured service, and the fourth step will be the Docker Compose file will start the container with their configured entry points. I'll explain what is entry points in detail in the coming session. Okay, but entry point is a starting point when the container is spinning up for the first time. Okay, so you can control what data needs to be added, what files needs to be added, all these things you can configure over the entry points. Okay, so we have started spinning up the container, so it is getting created. See here, MS SQL container is already created, Solar container is created, and the Solar init job, okay, that will create Solar course, that is also done, and extended job is created, identity service CM is created. Then we need to have um, Xconnect and all, so it's being created. Okay, so if you notice here, I have used the flag -d. It's called as detached mode. It tells the Docker to start the container in the background and leave them running. Okay, if you omit this, the container logs are streamed to the output instead. So here it will be, all the logs will be streamed, so you have to type Control C to return to the prompt. So doing Control C sometimes stops and remove your container as well. Okay, so always better use -d. Okay, um, fine. The container is getting created. Yeah, it will create in 1 2 minutes. So the first time while you are spinning up the container, all the images will be downloaded. It will take time. So for the first time, it will take around 1 to 1.5 hours, something like that. Okay. So based on your internet speed and everything. Okay. But I have downloaded the images. Okay. I have stopped the uh, Docker containers. Okay. Now I'm making up, spinning up. Okay. So it's faster now, but in the very first time it will take time. Okay, for this demo purpose, for this session, I have already downloaded all the required image. Okay, so while it's coming up, I can show you one more thing. So as I told you now, this is the Docker for desktop. So I have installed it. Okay, so you can use this, using this tool only we will do our local development. Okay, so see here, here we have okay, so once okay, I can show here. So once it's installed, okay, you can run it. Okay, the first time. before you can spinning up the compose, otherwise it will throw an error. Okay, so here first it will be running on Linux mode. Okay, so what do you have to do? You have to switch to Windows containers first. Okay, then it will be prompt like this. Okay, so here in the image tab you can see all the list of image. See here we have solar image and we have int image. All these images are getting downloaded here already. And in the containers tabs, okay, so you can see the containers started spinning up. Okay, so from this tool itself you can stop the container, and you can go to CLI of this container, and you can delete the container, you can restart everything you can do. Okay. Okay, so now you can see all containers are up and running without any issues. Okay, so you can start consuming the containers. Okay, to see the containers that you have created, okay, you can use the command docker ps. Okay, so it will list down all the containers which is running. Okay, and also even you can see the containers as I told now in this docker text of Windows as well. Okay, so if you see here, you can if you type docker ps, you can see the list of containers as I said with the container ID and the image from where based on which image the container is getting created, and when it created, and what is the status, whether it's up and running or it's healthy, all these things, on which port it is running, all these things you can see. Okay, you can access the container service by the reverse proxy with the HTTPS protocol using their configured host names. Okay, so we ran init PS1, right? That will also add the host entry for all these required roles. Okay, so it's already added. So see here. See here, what is the host for CM, what is the host for INT server, everything we have configured in the environment variable. So with that, it will add host entry in the host config file. Okay, I'm trying to access the CM with this URL. See here, now the container, the CM container is up and running with this default stuffs. Okay, so if you want to go to Sitecore entry, okay, so here admin passwords could be password 1 2 3 4 5. It's a default password. And you can access solar on port 8984. Okay, and you can access SQL on the port 14330. Okay, the traffic can be accessed. Okay, see here the Sitecore is ready now for use. So traffic will be running on the port 8079. You can check what are the options available in the traffic. Okay. Uh, okay, so all these ports are defined here in the compose file. Okay, so see here traffic, what is the port, what is the host port, on what port it is running inside the container, and if you see at CM, okay, So here you can see this depends on INT service, okay, and depends on service, extended service. All this will be configured here. Okay, so based on this configuration, the container will be created and spin up. So great, we have created our first Sitecore instance running on container. So this is how you have to create a container. So this session we have seen the vanilla instance, but in the coming session we can see how to create custom image and how to um, use models, everything. Okay, we'll discuss. Okay, to stop the Sitecore instance. Okay, so what you can do? Simply you can use Docker Compose down. That's it. So all the containers will be stopped, and only the container will be stopped. The images will be persist. Okay, if you want to clean up the images, there is set up commands. Okay, so I have added one slide for contains all the Docker commands. Just go through this. Okay, so you will understand what are the commands we can utilize when working with Docker. Okay. So if you run Docker Compose down, then see here all the containers are stopped. Okay, then if you refresh, then if no more the containers will be available. That's it. Okay. So as I said, right, these folders, MS SQL, Solar Data. Okay, these are used as a persistent storage for the database and the index files. This means that your database and index data remain even after executing Docker Compose down command. Okay, however, there are a situation where you want to start fresh Sitecore instance, or you need to clear those these data due to stale data. For example, if you change the Sitecore admin password after creating the MS SQL database, okay, then yeah, there will be an issue. Okay, so to clean up all these things, you have to manually clean up, or you can use the clean ps script. Okay, so here I'll, okay, if you go to dot slash clean, then all the, there is a custom script. Okay, this script will be clean all the database files and Solar calls. Okay, so when switching between the Sitecore instance, always better you can clean this um, storage. Okay. Um, okay, guys, that's it. Pretty much I have covered everything what I wanted to cover. Okay. So, any questions, guys?
So, guys, do you have any questions? I think you have explained it pretty much clear, Nazar.
Yeah, thank you.
If we have question, we'll get back to you for sure.
Yeah, sure, sure. Always reach out to me.
So thank you so much, Nazar, for this wonderful webinar. It has been very great. Actually, seeing this Docker container session visually, actually, how it is hosting those things and all. On behalf of Shiksana, extending my thanks to all the participants. Thank you all.
Thank you, Vinodini. Thank you all.